Okay, so this presentation is going to be on the five senses: sight, smell, taste, sound, and touch. Our senses are obviously related to our nervous system, which we talked about in a previous video. So we're going to be mentioning the word impulses and action potentials. If you don't remember what those are, check out the other video or come and see me before or after school, and I'd be happy to review that with you. So let's go ahead and get into the senses. So let's begin with the sense of sight. So let's look at the anatomy of an eye first of all. Let's start from the outside and work our way in. So the outer covering, the outer protective layer of the eye is simply called the cornea. It's clear and allows light to pass through, of course. And when we move on in, we come to the colored part of the eye called the iris. The iris is a muscle. And so like any muscle, it's able to stretch and contract. The iris happens to stretch and contract whenever there is an abundant or a small amount of light present. So you might have noticed if you ever stare into somebody's eyes, the little hole in their eye, their pupil, which we'll talk about in a minute, the pupil will get bigger and smaller based on the amount of light that's in the room. Well, that's because of the iris. When it's dark, the iris will stretch open. That way, whatever light is in the room can hopefully enter your eye and you can see better. But in a bright room, the iris will not close completely shut, but will shrink. And, well, I don't know about shrink, I'm sorry. The iris will lengthen, to make the pupil really, really small, so not a lot of light can pass through. And so the pupil and the iris are most definitely related to one another. The action of the iris will adjust the size of the pupil. But one thing to mention, the pupil is not really an object. It's a hole. It's a hole in the middle of an iris. Like if you have a donut, the hole is not actually part of the donut. There's nothing there. It's just empty space. That's really what the pupil is. But again, the pupil and the iris have a relationship to one another because the iris will control the size of the pupil. As I mentioned, the hole is called the pupil, and the hole will be bigger in dim light. Well, that's because of the iris. The iris will open nice and will stretch and make the pupil bigger if it's really, really dark out. But the opposite happens in bright light. The iris will kind of close up, and so therefore the hole, the pupil, shrinks in bright light. Well, just behind the pupil, just behind the iris, we have the lens. And so if you notice in this picture here, the lens kind of looks like the shape of a football. And so it sits behind the iris, and when light enters the eye, light passes through the cornea, through the pupil, and through the lens. The lens acts like a magnifier, and so when light passes through the lens, the light is magnified and you're able to see objects a little bigger. So the lens acts as a magnifier. It also helps to focus light onto the back of the eye, which we'll learn is called the retina. So as light enters the pupil, it passes the lens, and in this diagram here, what looks like empty space in the middle of the eye, it's not actually empty space. It's filled with a gel, a watery gel that has nutrients in it, which will supply the eyeball and all the cells of the eyeball with much needed nutrients and water. And this is called the vitreous gel. And the vitreous gel is also is also clear. The vitreous gel is also clear, so light can pass through it. If the vitreous gel were all cloudy, that would impair your vision. And finally, we come to near the back of the eye, we have a layer of cells called the retina. And what's so important about these cells is the retina is the cells that actually allow you to detect vision. So they're at the back of the eye, and light will enter the eye. Light will pass the cornea, past the pupil, past the lens, pass through the vitreous gel, and light will strike the back of the eye called the retina. On the retina, there are two types of nerve cells. There are rod cells and cone cells, and you may remember that cone cells detect color, rod cells detect light and dark. So what the retina will do, the retina will create an impulse, an action potential. And the action potential, or the impulse, will then travel from the retina up the optic nerve, and the optic nerve leads into your brain, and your brain will interpret that impulse as vision. So we're going to go through the sight process in a little more detail on the next slide. So the process of vision. Here we have the same diagram with all the parts labeled. So step one in this process, light will pass into our eye, pass through the cornea, and through the pupil. So let's just say it's an average day out, not too sunny, not too dark, and so the pupil is open enough for light to pass through, and then when light passes through the pupil, the lens will focus light onto the back of the eye, the area known as the retina. So not only does the lens focus the light, I also mentioned earlier that the lens acts as a magnifier. So it'll magnify the images that we're seeing. And finally, well not finally, sorry, at the back of the eye we have the retina, and we mentioned that there are rod cells and cone cells on the retina. Rod and cone cells are examples of photoreceptors because they detect light. And so in our animation here, step number 3, we have an action potential, an impulse being created. Well, once the retina creates the impulse, that impulse will travel up the optic nerve, and up the optic nerve, which leads directly into our brain. And our brain will interpret that as vision. So here's a fun little test you can do. Behind the blue box on the left, I'm going to remove the blue box. I want you to tell me the color of the words that you see. So from top to bottom, there'll be about 8 words. Read them from top to bottom. Read the color that you see. Don't read the actual word. Read the color. Here we go. I'm going to remove the box in 3, 2, 1. That should have been really easy because the color blue matched the actual blue text. The word yellow is actually written in yellow letters. The word red is written in red letters. But now we're going to do what's called the Stroop Effect. It's a little fun way that we can trick our brain. I want you to do the same thing. Don't read the word. Don't read the word. Read the color. Read the color that the word is printed in. Read it from top to bottom. Here we go. 3, 2, 1. It's a lot more difficult, isn't it? Just because the color of the text doesn't match to the actual word, it's a little tricky on our brain. There's all little tricks that you can do to kind of mess with your brain a little bit and kind of mess with the impulses that are being sent to your brain. This one is called the Stroop Effect. So let's move on and talk about our sense of hearing. Well, let's look at the anatomy of an ear. First of all, the fleshy outer part of the ear, the part that people will decorate by piercings, is called the pinna. And it's the outer part of the ear, and it's shaped like a funnel. So what happens when sound enters the pinna funnels the sound into your ear canal. So the pinna is not simply just for decoration purposes. It actually has a role to play. It's the outer part of your ear, and it helps to funnel sound waves into your ear canal. Follow the diagram. We enter through the pinna and we lead into the ear canal and we come to the eardrum. The eardrum is a fleshy layer of tissue, and the eardrum will vibrate whenever sound enters your ear. And right behind the eardrum are the three of the smallest bones in the human body, the incus, the malleus, and the stapes. And so these are three bones that will help to amplify the sound so you can hear it nice and clearly. And behind those three bones, the incus, the malleus, and the stapes, is a curly seashell-shaped bone called the cochlea. So the inside of the cochlea, there's a fluid, and we'll talk about that fluid more in a minute. Inside the cochlea, there's a fluid, and there are also what are called mechanoreceptors. Mechano is simply a prefix that means pressure. There are pressure sensors, pressure receptors inside the cochlea. These pressure sensors, these mechanoreceptors, are what will detect sound. They'll create an impulse and they'll send the impulse into your brain. We'll go into that a little more detail on the next slide. So here we have sound transmission. So what happens is sound waves, which are simply vibrations of the air, will enter your ear canal. In this animation, somebody's listening to music. So the sound wave from the music enters your ear canal. In area 2 of the picture, we can see the eardrum and those three bones, the incus, the malleus, and the stapes, begin to vibrate. So the sound waves cause the eardrum and the three bones, the incus and the malleus and the stapes, to vibrate. That vibration is passed on to area 3 and 4 of the picture, the curly bone in the back of your ear called the cochlea. So sound will enter the pinna, be directed to the ear canal, vibrate the eardrum and the incus, the malleus, and the stapes. That will cause the cochlea to vibrate. That's what's happening in area 3 and 4 in the diagram. The cochlea is vibrating, and inside of the cochlea is a fluid. What happens is when the cochlea begins to vibrate, that fluid begins to move and slush around. And so what happens is as that fluid moves, the fluid causes cells called hair cells to bend. So the motion of the fluid in the cochlea causes what are called hair cells to bend. That bending process creates an impulse, which we'll see in area number 5. So here's a picture of those hair cells. See how they have little cilia sticking straight up into the air? Well, when fluid rushes over these hair cells, they bend, and when they bend, it creates an impulse. So if we come back to our diagram here, in area number 5, we have an impulse being created inside of the cochlea, inside of those mechanoreceptors that we mentioned a moment ago. The impulse will travel up what's called the auditory nerve. The auditory nerve picks up audio sound. So the impulse travels up the auditory nerve and directly into your brain, and your brain will interpret that impulse as sound. In this case, hopefully good sounding music. Well, let's go over our sense of smell and our sense of taste all on one slide, because you might know that your sense of smell and sense of taste are related to one another. Let's start off with our nose. So what we have here is a person inhaling blue circles through their nose. These blue circles are simply scent molecules. If someone sprays perfume in the room, then those blue molecules would be the perfume molecules. What happens is when you inhale them, those molecules dissolve in the mucus in your nose. And what happens then is those molecules cause impulses to be created. You have chemical sensors in your nose called chemoreceptors. The chemoreceptors will detect the chemicals that you smell. The chemicals will dissolve in the mucus in your nose, and that will activate an impulse to be created by those chemical receptors. So here we have an impulse traveling up what's called your olfactory nerve. Those little dark branches in the picture, those aren't nose hairs, those are nerves. And so when those scent molecules dissolved in the mucus, those nerves created an impulse. The impulse travels up the olfactory nerve into our brain, and our brain will interpret that impulse as a pleasant aroma. Let's look at the sense of taste on the right. Here we have, of course, a picture of a tongue. Our tongue is, of course, covered with saliva, and it's also covered, I'm sure you know, with objects called taste buds. So how do we sense taste? Well, let's zoom on in and take a closer look. Here's some microscopically zoomed in taste buds. And kind of here's an artist drawing of a taste bud. When we eat food, here we have these molecules representing food. So these molecules we're in a bite of our food. Let's say that these are salty molecules right here. The salty molecules from our food dissolve in our saliva. The taste buds will then, there they go, they just dissolved in our saliva. The taste bud has what are called chemoreceptors on it. Again, chemoreceptors means chemical receptors. The taste buds have chemical receptors which will detect the salty chemicals in the food, or they might detect the savory chemicals, or they might detect the bitter chemicals. And ultimately, the taste bud will create, the chemoreceptors will create an impulse. The impulse travels, this is actually called your cranial nerve, up your cranial nerve and into your brain. And our last sense is the sense of touch. We have all over our skin various types of receptors. Mechanoreceptors are just one type of receptors that we have. Mechano is a prefix that means pressure. You know we have pressure sensors on our skin. If someone touches you, you can feel the pressure of their touch. If you look in the picture, you can see that near the surface of the skin, in the upper layers, we have sensors to detect gentle touches. Deeper into the skin, you can see in the bottom right-hand corner, we have sensors to detect strong pressure. Here we have an insect flying around and landing on our skin. Well, we've all had insects crawl on our skin before, and it kind of tickles. The reason it tickles is, look in the animation. When the fly is crawling around on our skin, it causes our arm hair to wiggle. Look what's wrapped around the base of our hair. There are nerves wrapped around the base of our hair. Those nerves will create an impulse, leads to our brain. As I mentioned, in the lower levels of the skin, we have heavy pressure sensors. You can see some heavy, strong pressure sensors in the lower right-hand corner. Watch this. This is kind of a morbid animation. Watch this. Oh no, we have a knife coming and stabbing a person into the arm. Well, that stabbing process activated strong pressure sensors deep within the arm that will send a pain signal to the person's brain. Now there's a good chance the stabbing might also destroy the pressure sensors, but in this case we're just going to say that the person was temporarily hurt and eventually they'll heal, and the stabbing wasn't too serious. Well, if you notice, we have thermoreceptors all over our skin. Thermoreceptors detect hot and cold, and you know that. If someone comes up and puts an ice cube on the back of your neck, you can feel it instantly. If someone comes and touches you with something hot, or if you accidentally touch something hot, you feel it almost instantly. We have pain receptors all over our skin. If you've ever stubbed your toe, if you ever dropped something on your hand, if you've ever had a paper cut, you can see the pain sensors are just beneath the surface of your skin. That's why paper cuts hurt so badly, is because paper cuts activate pain sensors that are located just underneath the surface of the skin. Even though a paper cut is fairly mild, it can cause a lot of pain for that reason. And so the big thing I want you, of course, to see is that these sensors will send impulses to your brain. So your brain gets impulses all the time. Watching these notes, think about the impulses that are going on as you watch these notes. You have the visual, you have light entering your eyes, so your eyes are sending visual impulses to your brain. You're hearing my words right now, so your ears are sending auditory impulses to your brain. Maybe you can feel the pencil in your hand. Well, that's because you have pressure sensors in your skin, in your fingers, that allow you to feel the pencil that's in your hand. And so maybe you're chewing on gum right now. If you're chewing on gum right now, you have chemical sensors on your tongue to detect taste. And so we have all these senses that are going into our brain and being monitored daily, instantly, from the moment we wake up till the moment we go to bed, and I take that back, actually, from the day we're born until the day that we die. Here we finally reached the end. Here we have a practice quiz. So what I would recommend is try pausing this video and spend a few minutes to try to answer these questions. All of these can be answered by viewing the PowerPoint or viewing the video. So pause it, try to work out these questions. I'd be happy to check your answers before or after school. So write your answers on a separate piece of paper if you like. Bring them to me after class, and I'd be happy to check them for accuracy. Good luck.